So yesterday we just simply factored. Today our goal is going to be to solve, and that really is our goal for the rest of this chapter. How can we find x? Which is like math's greatest question. Can you find x? And that's pretty much what you work on all through algebra and pre-calculus, like finding x. In any equation that you're given, how can you find x? Why can't x just find itself, right? Why do we always have to find x? But we're going to see if we can find x today with this x squared plus bx plus c form by setting it equal to 0 and thinking about these two different questions. So we have a root of an equation versus a 0 of a function. So a root of an equation we consider to be a solution. Oh, there we go. To the equation. A solution is an answer. We're finding x. So if it says find the root of the equation, that's another way of saying find x, find the solution. The next term underneath is almost the same, but it says a 0 of a function. This is found by setting the equation equal to 0. So we either let y equal 0 or we let f of x equal 0. And anytime you do that, you're finding x-intercepts. So we're still finding x, but it's considered an x-intercept instead of just considered a solution. But they mean the same thing, because either way you're finding x. So we're setting y equal to 0 or f of x equal to 0 because we're finding x-intercepts. So anytime you take an equation and set it equal to 0, our goal is to find the x-intercepts. Where does the graph cross the x-axis? We will be taking equations today, putting them in intercept form, and actually getting the x-intercepts, which you already did to graph. It was just already given to you in intercept form. So today we'll be placing that equation in intercept form by factoring so that we can find the x-intercepts. So a root and a 0 are really the same thing. We're still finding x. We're solving for x. So if you see either one of those terms, both of them just mean find x. The other little definition underneath here is actually a property. Kind of like geometry where you have all those theorems. We have a little bit of properties in algebra that we talk about. And this one's called the zero product property. So product means what? If you have the product of something, what does that mean? Melanie? The answer of a multiplication problem. Factoring is multiplication. So the zero product property goes along with factoring. So if the product, meaning we have a multiplication problem, that's the answer to a multiplication problem, of two expressions is 0. So I have these two expressions, they're equal to 0. Then A is equal to 0 or B is equal to 0. So if I'm taking A times B and it's equal to 0, that's what the product means. If both of them are equal to 0, the way you get 0 is either A is 0 because 0 times B is 0, or B is 0 because A times 0 is 0. Kind of makes sense. One of them has to be 0 if it has to equal 0. So underneath, we have that like same little thing here, the algebra. If A and B are expressions, A times B is equal to 0, then A is equal to 0, B is equal to 0. They kind of mean the same thing. They're just explained slightly differently. The algebra is where it's going to help us a little more. So if we have an algebraic problem, x plus 5 times x plus 2 is equal to 0. This is what our factoring problems look like. So when we factor, we get it to be a product of two terms. So the zero product property says that you can take a piece of that factor and solve it by setting it equal to 0. So if I separate each of them, then you have one expression that says x plus 5 is equal to 0, a second expression that says x plus 2 is equal to 0. So essentially you're allowed to take this product, split them apart, and solve individually for both pieces. So the two values that we would have for x would be what if you solved each of those little equations? X plus 5 equals 0, x plus 2 equals 0. Julia?
-5, -2.
Right, -5 and -2. Those are the x-intercepts. Those are the solutions for x. So factoring us enables to get these terms in parentheses that we can then take those two pieces and solve for. And that's all the zero product property says. But it has to be equal to 0. So if it isn't equal to 0, then you've got to set it equal to 0. That's the zero product property. It can't equal 5. It can't equal 15. It can't equal -10. So you can only solve when it's equal to 0. Cannot equal any other number. Zero product property. So the example underneath says find the roots of the equation, which means to solve. So find the roots is another way of saying solve for x. Don't let the directions confuse you. How do you solve for x? We have x squared minus 2x minus 15 equals 0. How do we find x? Factor it, yeah. So now that's the method that we're using to find x. You cannot take the 15 to the other side, try and divide an x out. That does not work. Algebraically, it's not equivalent. So factoring is our way of finding x. Calvin, what two numbers multiply to be -15? And how would they combine to be -2? X plus 3. And he said x minus 5. So now the zero product property, they're both equal to 0. So you can individually solve them and find the x values. And because there are two solutions, they're going to be two answers for x. So Gavin, one answer is, and our second solution, great. So that means if you plug a -3 into the original equation, it's going to give you a value of 0. If we plug a 5 into the original equation, it's going to be equal to 0. These are also x-intercepts. So if we graph the parabola, these points would be 2 points that we could plot on the parabola. Questions? So there's another one underneath. The only difference is it asks you to find the zeros. So find the zeros of the function, which means find x, the x-intercepts, by rewriting the function in intercept form. So to find the zeros, we're going to set it equal to 0, so that y equals makes it a function. That's a graph parabola. We're going to take this standard form and make it look like intercept form, which is really just factoring. So Will, if we have a -6, what two numbers multiply to be -6? Okay, so you said 2 and 3. What else multiplies to be 6? 6 and 1. We're trying to make a 5. And we need it to multiply to be -6. How would one of those pairs combine to be a +5, but multiply to be a -6, Will? Yeah, so a +6 and a -1. Because 6 times -1 is -6, but 6 minus 1 is a +5. So x plus 6 and x minus 1. So Will, the two solutions, if we set each of those equal to 0, would be what?
X equals 1 and x equals -6.
Good. So we're going to graph this. Underneath it says, well actually you can see the graph, but I want to show you in the calculator how to get these numbers. So graph y equals x squared plus 5x minus 6. And then it says the graph passes through these 2 points. If you take out your calculator, so this year we will use the calculator a lot to kind of support our work, check our work. Not always to rely on it, but as a way to check ourselves. So if you go to y equals, make sure your equations are cleared out. we're using that equation x squared plus 5x minus 6. So it's just y equals, where you usually graph everything. Hit the graph button. And we have this lovely looking parabola. And you can see that the parabola is crossing over the x-axis. Sorry, turn that off. And it's on the floor. Alright, so x-axis is what we're looking for because that's where the graph crosses the x-axis. That's our x-intercepts. I'm going to show you how to find them with the calculator. So if you hit the second button and trace, we've used that to find a max or a min with the parabola. We used that when we were graphing two lines and finding where they intersect. There's a lot of stuff underneath that calculator. Today, we're going to be using number 2 because we're finding zeros of a function. The calculator finds zeros of a function for us. So we're going to hit number 2. And here's where the part is a little tricky. So I'm going to start over here on the left side. So I'm just using the left arrow to get my graph, my little blinking guy. There we go. Okay, so here's my little blinking cursor. He's going to be your friend. Right now it looks like he's really close to the x-intercept, but he's not quite on it. The calculator wants a left bound. That means it wants a number to the left of your x-intercept. So right now I'm kind of on it. I'm just going to move slightly to the left by using the left arrow. And then you hit enter. And that little pointing arrow goes up at the top to show you that that is your left bound. Right bound means we need to move to the right so that we're slightly to the right of the intercept. In this case, it's kind of like we're underneath it, but you really are to the right of it. You'll hit enter, and now I have those two arrows pointing towards each other. In between those two arrows is where the x-intercept is located. You never do anything for guess besides press enter. And it tells us that we have a 0 at -6, 0, which is exactly what Will said for factoring, but now the calculator is doing it for you as a way to check your work. So again, do it a second time. Second trace. Hit number 2 because we're finding zeros. You need to take your little blinking guy to the other side of the graph because it needs to be close to the x-intercept that you're trying to find. Alright, so I get as close as I can to it, and then left bound means I need to use the left arrow. It has to be on the left side of it. I hit enter. Right bound means I'm using the right arrow, and hit enter again. So those 2 points should never overlap. They should be pointing towards each other, these little arrows up here. And then in the middle of those arrows is our x-intercept, or 0. Oops, I hit mine too many times. That wasn't one. So you should have that saying, a -6 was the value we found the first time, a positive 1 is the value we just found. Questions? So the calculator finds a max or a min, it finds where graphs intersect, it now finds where we have zeros, where the graph's crossing the x-axis. Great way to check yourself. So if you're not sure how something factors, or you kind of want to see, are you factoring it correctly, you can check yourself by graphing it in the calculator. Questions? So again, that was second trace. And number 2 is the 0 function. So we use 4 different functions in that second trace area for calculations. So there's one final problem that we're going to work on today. And of course, it's an application problem. Try and apply the things that we're doing to something outside. In the real world, as close as we can get to the real world. Sometimes still probably wouldn't do it, but you never know. This one, maybe you might think about doing, maybe your parents want to do something like this. But we have a nature preserve. I've got a nice fancy telegraph up here picture. A town has a nature preserve with a rectangular field that measures 600 meters by 400 meters. So that's this area here. So think of like North Park. They have a little area in North Park donated to, like, dedicated to the dogs. I think there's a dog area where you're allowed to take your dogs in North Park, so that kind of thing. The town wants to double the area of the field by adding land as shown. So currently, we have this space, but we want to extend it and make it bigger by doubling the size. We're going to add an extra distance of x to this side. We're going to add that same distance of x to this side. Now, that doesn't look like it's drawn to like show equivalency, but if it's x, that has to be the same distance you're adding to both pieces. Because if we use x in both times, it has to be that same value. It says find the new dimensions of the field. So let's talk about the current dimensions of this field. If we want to double the area, a little bit of geometry, how do you find area of a rectangle? Julian? Yeah, area is equal to length times width. So Julian, what's the area currently that we have of this nature preserve?
400 times 600.
So currently it's 400 times 600. Which is 240,000. And this would be meters squared. That's the current space, which seems like a pretty big space. But we want to double that area. We want to make it even bigger. And to do that, we want to double it by adding extra space to the length, adding extra space to the width. So we know that area is equal to length times width. Our new area has to be equal to the new length times the new width. Still length times width, but now we got this new space. We're increasing it. So what is the new area supposed to be? How big is it going to become? We're doubling it. Julia?
400 plus x times 600 plus x.
So she said the new length would be 400, the current length, plus this new distance of x. So we have 400, we're adding an x to it. We're increasing it by some amount of space. Maybe it's another 100 meters, maybe it's only 50 meters. But that space has to increase our current x value. Julia, what's the new width going to be?
600 plus x.
Yeah, so we currently have 600, but we're increasing it by that same distance of x. So we're adding the same space to the length and to the width. We don't know what it is, but we know we want to increase it. Increase means add. We want to make it bigger. We don't want to make it smaller. Julie, what's that going to be equal to if we're doubling this space?
2 times 240,000, which is 400,000.
Do I not have enough zeros?
So you don't have
I don't have enough zeros. I'm sorry. So this should be, I missed a zero, because there are 4 zeros up there. So 240,000 becomes 480,000, she said. So doubling this area means we need to multiply the area by 2. Here we have the length and the width. So our new length and new width. What do you think you'd have to do with this? So we know it's supposed to be equal to 480,000. That's the new space this is going to take up. What do you think you're going to have to do with this side over here? The right side of the equation. Melanie, you want to take a shot at it?
No.
No? Any suggestions? 0 product property, we can't solve it if it's not equal to 0. Emma? So we can't break it up. Yeah. Because it's not equal to 0. So So zero product property says it has to be equal to 0 in order for us to break those pieces apart. What else can you do with it if you can't break them apart? Julia? Yeah, we're gonna have to FOIL these. So we actually have to FOIL first so that we can then eventually get this set equal to 0. So you might need to use your calculator. 400 times 600, make sure you have all those zeros. I missed the zeros the first time. So that's 240,000. And then we have plus 400x plus a 600x and then plus x squared. Zero product property must be equal to 0. So combine your like terms, but also we need to take the 480,000 to the other side. You cannot solve unless it's equal to 0. It's not allowed to be equal to anything else. So x squared can go in the front. This makes a 1,000x. And then we have a negative 240,000. All right, so this is a huge number that we're going to try and factor. We need to figure out two numbers that multiply to be 240,000, but add to be 1,000. I'm going to show you a little shortcut. Julian, what do you think we could kind of think about because this number's so big?
Could you divide both of them by 1,000?
Okay, so if we divided it by 1,000, that would kind of break down the problem a little bit. So do you have a pair of factors that might work?
Well, I had 600 and 400 for the just without doing.
Okay, so you were thinking 600 and 400. But 600 and 400, because this is a negative number, they would both have to be positive, so that's not going to quite work. Just think of like 24. Like, don't think about all the extra values. Rebecca, what do you think?
2 and 12.
Yeah, so 2 and 12 make 24. So Rebecca, 200 and 1,200 would make 240,000. So if you just think about the 24 in front, kind of focus on that number. And then we can kind of focus on the 10. So if we have a positive 1,200 and a negative 200, they multiply to be negative 240,000. They add to be 1,000. So x minus 200, x plus 12,000, or 1,200, not 12,000. Now you can solve for these because they're equal to 0, so you can now split them apart. And we get negative 1,200 and positive 200. So we have two answers. Which one of those answers do you think is correct, Rebecca? Why not the negative 1,200?
Because you can't take away when you're adding on to the base.
Yeah, so you can't have a negative one. That means we have a positive value, so the positive 200. You guys are packing up on me. We got 3 minutes. Do not pack up on me. This is honors algebra 2. Should be packing up early. We still are going through this problem. I still got time. So it says find the new dimensions of the field. So my value for x is 200. My original dimension was 400 by 600. And we are using 200 as the new value for x. So you can't use the negative number. A negative area doesn't exist. A negative number doesn't exist. So our new dimensions, if I'm adding 200, originally we had 600 by 400, so now we have 800. Put meters there so it's labeled. By 600. And those new dimensions should give us the 480,000 square meters. Questions? So your homework for today, you have 25 to 55 odd. Those are just traditional factoring, but you're setting it equal to 0. And then there are 3 problems, 40 or 59, 61, 65, that are more like doing a little extra thought process to the problem. So volunteer for 59 and 65. Connor, you want to try 59? How about 65? Brandon, would you try 65 for me? Thank you.